Let's look at number 11. Under ideal conditions, the population of a certain species doubles every 9 years. If the population started with 100 individuals, which of the following expressions gives the population of the species T years after the population started, assuming that the population has been living under ideal conditions? So we have four different exponential equations here, something times something raised to something. And I have bit of an outline for us to take a look at here. Here is the first box of something times second box something raised to our third box of something. Now, the first box here, that should be your starting amount. And we know what our starting amount is in this case. That is the 100. And then times our second box here, the base of our exponential function, that is the speed of the growth. If it's like doubling or tripling or quadrupling, that's where that number goes. In our case, we're doubling, so we need to put the number 2 right there on the bottom. If we look at our answer choices, that eliminates answer choice A and B. The 2 and the 100 are in the wrong spot. So C and D is what we're leaning towards. Now I just need to figure out how many times it should be doubling or how frequently it should be doubling. So it said if it doubles every 9 years. So I need to imagine that in 9 years, 9 years, that should only be one doubling. One doubling. So at the very beginning, we have 100. In 9 years, we should have 200. Then in another 9 years, that would be a total of 18 years. That would be two doublings. Two doublings. And then in another 9 years, in 27 years, that would be three doublings. Three doublings. So I need to make sure that whatever expression I put up here in this exponent turns this number of years into this number of doublings, because that's what the exponent represents, is the number of times that it's doubling in this number of years. So if I look at those choices, whoops, if I look at those choices, here on answer choice C, we have 9 times the number of years. If I were to plug in 9 years, 9 times 9 would be 81. That would be 81 doublings in 9 years. But that's not right. I'm not supposed to have 81 doublings in 9 years. I'm just supposed to have one doubling in 9 years. If I look at answer choice D and I imagine plugging in a 9 for that t, 9 divided by 9 is 1, so that would be one doubling. And that is what I was expecting. If you plug in a 9, you should get one doubling. If you plug in an 18, you should get two doublings. Let's look at that. If I have that t right there, if I plug in an 18, 18 divided by 9 would be 2. So that would be two doublings. That is what we want. So we don't want to multiply the number of years by 9. We want to divide the number of years by 9. Answer choice D is what we're looking for on this problem.